everyone, this is Sohit, and in this video we are going to solve the problem of the day of GFG. Today is 29 July 2026. So let's solve the problem. So it's a very easy problem, you can easily solve. So let's see what we have given. We have to split an array into minimum subsets. Okay, so we have given an array of distinct positive numbers. Split the array into the minimum number of subsets such that each subset contains consecutive numbers. What does that mean? In this, let's suppose we have given this array and we have to find out the number of subset which having the consecutive numbers, okay, from that array. So just we have to return the number of subsets. That's it. Okay. If I tell you in other way, so let's see. This is the example. We have given this array and the approach which we are using over there, which is the brute force approach. We can say this is a brute force. Otherwise, we have another approach as well, big of and square approach as well. But this approach is big of and log n. Okay. So what we have done over there, we have first of all we have sort the array. Then we made a count variable, and then we started a loop from 1 till the length of the array. So what we are checking, if array of I is not equal to array of I minus 1 plus 1, then we just need to increase count. So what is this and how it's working? So let's see over there. Okay, this is the initial array. After sorting, it will become like this. Okay, now what logic is, if array of I is not equals to array of I minus 1 plus 1, means the current element is not equals to the previous element plus 1. Okay, so here let's we take 6. So current element is 6 is not equals to 5 plus 1, which is obviously equals to. So that's why we just do nothing and we just increase. Okay, we just increment. If this condition came, current element is 56 and the previous one is 7. So 7 plus 1 will become what? 8. Okay, so 8 is not equals to the current element, which is 56. So that's why we will increase the count. If this condition follows, we just increment the count. That's it. And at the end, we will return count. Okay. So the main point is over there. We have to focus. We have initialized the count as 1. Okay. Why so? Because this condition will meet at n minus 1 time. So, I mean, let's suppose there are 3 subarrays. Okay. So this condition will meet only 2 times. See, first it will meet over there, and then second it will meet over there. That's why we know that it's 3. Okay, but the condition is meeting 2 times. So that's why we have initialized the count as 1. The other another reason we can say, initially we would have at least one element, so it will be considered as an element. So that's why we have taken the count as 1. Force 1. Is this approach. Okay. So I will tell you how to think. Here you see we are sorting and then checking. Okay. So what to do such that we no need to sort, because that's why only we will able to get the big O of n time complexity. So big O, so I have one idea. What we will do, we will take this array and take the minimum value and take the maximum. Okay. And store all the elements in a subset, or we can say in a HashSet. Okay. Why we are doing this? Because by using this, we will able to get the next. We will able to check whether the next element is exist or not. Because the subset HashSet has a one method called dot contains. Okay. And this method have the time complexity of bigger of one. So that's why we are using here HashSet data structure. Now we have minimum, we have maximum. We will start a loop from minimum to maximum. Okay. And we will check if the element, let's suppose we have an iterate, let's suppose which is till the maximum. Check if the num plus one is exist. Till then we will just increment our num. Okay. The num. And at that time, because we will get one subset which has the consecutive. So that's why we will increment our count by 1. Okay. So in this way, we can solve the problem. But if we see very closely, then we doesn't require the minimum and maximum. If you look very closely, we doesn't require the same. This is the optimized approach that the big of. In this, what we have done, we have created a hash set and a counter variable which will start from 0. Okay. First of all, we will store the elements of the array into our hash set. Okay. Now this part is done. Now see the core logic. What we are doing, we are checking for each number in the set if set contains the previous of that number. Then we just increment the count. That's it. Okay. For example, if we take this one, okay, 100 in this array. So in the set, it will be 100, 56, 5, this kind. Okay. Now what will happen? We will check set dot contains num minus 1. Okay, 100 is over there. Is our set contains 100 minus 1? Is it contains 99? No. That's why we just increment count plus plus. Go to the next element 56. Same way. Is the set contains 56 minus 1? Which means is it contain 55? No. Just increment count. So count become 2. Now reach on the 5. Now our set contains 5 minus 1. Will it contain 4? No. So that's why we will also again increment count. So this will become 4. Now check. This is 6. And set dot contains 6 minus 1, which is 5. Yes. Obviously 5 is over there in the set. So that's why we no need to increment. So our count is what? 3. In the same way, we will check for 102. Is set contains 102 minus 1, which is 101. Yes, set contains. No issue. So we no need to increment. In the same way, 58. We will check for 57. Is the set contain 57? Yes, it contains 57. Then no need. Again, we will check for 101. Is the set contains 101 minus 1, which is 100? Yes, set contains 100. So we just no need to increment. Okay. In the end, so we have counted what? 3. So likewise, it will go and we will have the count value is 3. So we just return the count. That's it. That is the logic. Okay. So what we have learned over there, we have the brute force approach in which we need to sort, and based on the sorting, we are finding the critical points where the changes happen. Okay, we will detect the changes, and as these changes happen, then we just increment our count. Okay, so how we minimize this complexity? So first of all, we have to think like this. There is n log n. So we need to get answer in big O of n. Okay, so sorting is not the correct way. So what we have done, we take the minimum and the maximum element from the array and run a loop on from minimum to maximum. Okay, then we will store all the element in the hash set because hash set had dot contains method, and the average case time complexity of dot contains method is big of 1. So that's why we are using this. Okay, if our set contains the element, then we just increment the num value until the num plus 1 doesn't exist in the set, and at that time we just increment our count. Okay, so in this way we will get our answer. But if we look very closely, then we doesn't require the minimum and maximum. Why so? Because the set has the all the element. Okay, so that's why we came up with this solution. We make a set and add the all the element from the array and make a loop on it and check the condition. If set contains num minus 1, then no need to increment. If it doesn't contains, then just increment and just return count. So I hope you get the idea about the problem and how to solve and how to reduce the time complexity. Okay, all about for today's video. If you like this video, so please make sure you subscribe our channel and like the video. Thank you. Thanks for watching. If you have any kind of doubt, so you can leave a comment and ask me directly. Okay, thank you. Thanks for watching the video.